be talking about trigonometric equations. So now let's start to create an example for such a trig equation. So we have 3 sine of x, let's say minus 2, is equal to 5 sine of x minus 1. Okay? In trigonometric equations, we are interested in solving for x as usual. Whenever we are given an equation in math and they say solve this equation, we want to find out what x is. Notice that in this setup, x is really covered by sine. What do we mean by that? Well, we could have put parentheses right here. That means that x is buried inside that sine, meaning sine of x is whenever we evaluate x with the sine function. So in order to find out what x is, we have to actually remove that sign to solve for what x is, because we're interested in knowing what x equals. Okay? To do so, we group like terms. We have a sine of x and a sine of x here, so I'll subtract 3 sine of x from both sides, leaving 2 sine of x minus 1 on the right hand side and just a negative 2 on the left hand side. Okay? Then I can add a 1 to both sides, grouping like terms again. So I get a negative 1 is equal to 2 sine of x over here. Now, we aspire to find out what x is. So in order to first find out what x is, we first have to find out what sine of x is. So we divide both sides by 2. So I get sine of x is equal to negative 1/2. And so you guys now know, because of the videos in the previous videos, that now it's required that we take the inverse sine function of both sides. Because when we do so, the sine inverse of sine of x will just leave an x. So whenever I take the sine inverse of both sides, that means I get the sine inverse of negative 1/2 will be equivalent to x. Now, whenever we find out what sine inverse of negative 1/2 is, that is when we will be able to determine what is x. Okay? And so in order to determine what the sine inverse of negative 1/2 is, we have to actually look at the unit circle. Let's draw this unit circle out here. This is asking us a question. It's saying, at what angle does sine assume the value negative 1/2? Well, we know that that must be in the 3rd or the 4th quadrant, because that's when the y values are negative. Notice that over here the y values are 0, and over here the y values are 0, and slightly below the y values are negative 1/2. And so over here and over here we have the sine value at negative 1/2, and we can see that over here this is really 2 pi minus a pi over 6, because pi over 6 is the same thing in radians as 30 degrees. And over here, this is at the angle pi minus, pi plus pi over 6, actually. Because over here, we're at 2 pi, and then we want to rotate backwards to find out what this value is. Here, we're at pi, and we want to rotate forwards to find out where this is. Hence, where we add here and subtract there. But notice whenever you do the calculation, we get 6 pi plus pi all over 6. That's 7 pi all over 6, okay? And over here, when you do the calculation, that's 12 pi minus pi all over 6. So that means I get 11 pi all over 6. So these are the two answers, 7 pi over 6 and 11 pi over 6. Now, notice that these are our answers, but what if I were to add a 2 pi to this? Would I land in the same spot? Absolutely. Adding 2 pi just makes you rotate and land back in the same spot. So because of that fact, this plus 2 pi is also a valid solution for the sine inverse of negative 1/2. This plus 2 pi is also a valid solution for sine inverse of negative 1/2. This plus 4 pi is also true for this. And this plus 6 pi is also true. This minus 8 pi is also true. This minus 12 pi is also true. Are you catching the trend? Whenever you add and subtract multiples of pi, you'll still end up getting the same value for x here. So that as a consequence of the fact that sine has period 2 pi. And the addition of any integer multiple of 2 pi will land you back in the same spot. Hence, its sine inverse will evaluate at the same value for x. So x is actually separately equal to 7 pi all over 6 plus 2n pi, and x is this also equivalent to 11 pi all over 6 plus 2n pi, where n is an integer. Okay? When n is equal to 0, okay, these two terms vanish and we restore this and this. And then when n equals any other number, positive or negative, we still will get that the sine inverse of negative 1/2 will result in what we have here. Okay? So that is one example. Let us check the video out here, see if it ran smoothly.